Alrighty then, if you've been following along with videos, you'll know that this is actually in week 8, and this is going to be the last time you get to hear me blather on about statistics. So there you go. It's a joyous occasion, I guess. So here we go. We're going to just hit a little bit about confidence interval basics for this. We're not going to get wrapped up into a ton of calculations. There's going to be ones here or there that we have to go over, but really this is more about just the structure of how a confidence interval is put together. Now, if we look at a confidence interval, and I highlight the important part here, is the point estimate plus or minus a margin of error. So that point estimate is going to be from that sample. It's going to be the proportion of students that brush their teeth every morning, something of that nature. It's going to come from the sample, and then with that, we're going to have plus or minus what's called a margin of error, or abbreviated ME, and that's what we're going to focus on mainly in this. There's just some other things that we'll hit as we go through this. These notes are way more than you need. I pulled them from another resource, slapped them all in there, and instead of trying to hit and miss on what to leave or take, I just left them all there. When we get to it in equation form, it looks like this as far as we're only going to work on a 1 sample proportion Z interval. We have such things as a 2 sample, but we aren't going to hit that for sure. Anyway, again, here's that point estimate in the middle. This comes from the sample, and then we're going to calculate a margin of error, okay, as far as plus or minus a certain value to feel comfortable that we've captured the true proportion. And there is that. So, and then we'll do that for a proportion, and then we'll do that for a mean as well. So we see the mean equation's a little bit different. But in reality, my calculator is going to do absolutely everything for us. We just have to know what buttons to press. So here we go. A TV newscaster reports the results of a poll of voters and says the margin of error is plus or minus 7%, and explain carefully what that means. So when we talk about that, okay, so in a confidence interval, we are trying to estimate for the true proportion. Okay, so that's what we're trying to estimate a value for, is that true proportion. And therefore, with that margin of error is plus or minus 7%, we know the true proportion of voters, or the true proportion is within 7% with some degree of confidence. Okay, the confidence could be 95%, could be 99%, 90%. It's just that will have an impact then on what we have there. Okay, so for each situation described below, identify the population, the sample, what P and P hat represent, and then tell whether it is an appropriate to create a 1 proportion Z interval. So police set up a checkpoint at which drivers are stopped and their cars inspected for safety problems. They find that 20 of 133 cars stopped have at least 1 safety violation. They want to estimate the percentage of all cars that may be unsafe. So again, we are trying to find the proportion of all cars. That's why, again, we're trying to estimate I'm going to take this sample, and I'm going to see if I can take the numbers from the sample and apply it to the entire population is our goal here. So here it is. The population, then I'm trying to make an estimate for all cars on the road, okay? And the sample would be cars stopped at checkpoint. What does P represent? Okay. P equals the proportion of all cars with a safety violation. Whereas in P hat is going to be the proportion of the sample with safety violations. Okay, so that is the key difference between that notation. P is going to represent the population, P hat is the sample. And then say, is this appropriate or not? And Again, it goes back to if the sample is representative, then it is appropriate. Okay. All right, so trying again. An online blog puts on a poll on its website asking readers to rate the quality of its articles. Of the 687 people who voted, 520, 527 rated the articles very highly. The blog is interested in gauging its user satisfaction. So, again, identify the population. Okay, that I'm assuming that's going to be about the general public, or it's talking about user satisfaction. So I don't know if a general public, and again, this is going to be me not knowing what Excel has for answers. It just may be readers of blog. I don't know. That'd be a good question. Is that when you go through it, what you'll see? Okay, the sample. That because it was they just put a poll on their blog website. That's just going to be the people that the people that went to the website and responded. I mean, you could have gone to the website and not done anything. You could even read my handwriting. I'm getting pretty sloppy today. All right, slow down. All right, our P is going to be the proportion. What was the quality of it? The proportion of all readers Actually, let's back up a second. We're going to do the proportion of the population that would think articles are useful. And P hat is the proportion of the sample that would think the articles are useful. And because not appropriate, again, it's not a random sample here at all. This is a voluntary response sample. And it will likely have a biased outcome. So it would not be appropriate here. All right. A research institute wants to know if the eating habits of employees to know what to serve for lunch. It mails out all of its employees a form which to write down their favorite foods. Of the 1402 forms sent out, 339 are mailed back, with 154 listing pizza as their favorite food. Again, we're going to go through these things. Identify the population. So in this case, it's all employees. At Research Institute. Okay. The sample. What data am I specifically looking at? I'm looking at the 339 that returned survey. 339 returned surveys. The population parameter, or P, is going to be the proportion of all employees. Choosing pizza as favorite food. Whereas P hat will be the proportion of the sample choosing pizza as favorite food. And again, this is going to be have a non-response bias to it because I didn't get it back from everybody. So our interval is not appropriate. Again, the question was, can I use a one proportion z interval procedure? And so the non-response bias, so not appropriate. All right, a college admits 1546 first-year students, and 4 years later, 1152 of them graduate on time. The college wants to estimate the percentage of all first-year students who enroll at that university who graduate on time. So when we talk about this one, there it is. My population is going to be all students at university. My actual sample is going to be the 1152. The sample is the 1152 that entered last year. Excuse me, the 1546, not 1152. No, it would be the 1156. No, I had that right in my brain. Looking at too many things. 1546, that entered. Okay. The parameter here, P, is going to be the proportion of all students who graduate on time. And the p hat is the proportion of the sample graduating on time. And so this is a cluster sample. So if that cluster sample is representative, then it is appropriate. There are several factors involved in the creation of a confidence interval. Among them is the sample size, the level of confidence, and the margin of error. So which one of these are true? So again, this is going to be a little bit hard as far as we're just going to, again, we kind of use the questions as my avenue to teach the skills, and then we'll do it that way. So for a given sample size, higher confidence means a smaller margin of error. So what that means is if I'm going to create a confidence interval, okay, an interval of numbers. I might be 90% confident that I capture, so somewhere in there is the true proportion. I am 90% confident that I captured the true proportion. So to be, let's say I want to increase that confidence. Let's say I want to increase it to 95%. That means to be more confident that I captured the true proportion, I am going to have to increase my margin of error. So the middle here is the same on both, but my margin of error is what I go in each direction. So therefore, in order to be more confident, I have to increase my margin of error, okay? So that means for a given sample size, the higher confidence means a smaller margin of error. This one is going to be false because it's going to mean a larger margin of error. For a specified confidence level, larger samples provide smaller margins of error. And this is going to be true. And this is where we're actually going to go to the equation just a little bit. So this is dealing with proportions. So this is p hat times 1 minus p hat all over n. And then there's a z, a critical value out in front of this. So this is my margin of error. Now, what we're talking about here is we're talking about larger samples. So what's going to happen here is I could make my, let's say if I made my sample larger, let's say I put a 4 there. And then I just separated that out. I have the square root of p times 1 minus p. and I have the square root of 4 and the square root of n on the bottom, well, I can take the square root of 4. The square root of 4 is 2. So what happens is that by quadrupling my sample size, I end up making my margin of error half as small, okay, because the square root of 4 is 2, and so that means it ends up being half as big. Okay, so for a next one, for a fixed margin of error, larger samples provide greater confidence. Okay, and so what happens is, again, like this one above it, as the sample size increases, all right, so by increasing it by 4, we changed it by a factor of 2. Therefore, my margin of my standard error, okay, so if I highlight this, this is my standard error. It's going to get smaller, so that means that what happens, this z value is this is how confident I want to be. Okay, so z equals 1.64 to be 90% confident. Z equals 1.96 to be 95% confident. And I think z equals like 2.16, I can't remember, to be 99% confident. So what happens then, as this part here in yellow goes down, that means that this part has to go up in order for that fixed margin of error to stay put. So therefore, larger samples provide greater confidence is going to be true because of that fact. And for a confidence level, having the margin of error requires a sample size twice as large. And actually, we just did that up above. This one's going to be false. Again, to make it decrease by half, we actually need a sample size. I will highlight that. We need a sample size of increase of 4 on that. Okay, so we'll just draw an arrow there. I don't like that. We'll change this back to a pen, and I'll draw a line up there. It's actually going to be 4. Okay, so now let's try, we'll get into some actual confidence intervals here. A poll conducted by the UC Berkeley Institute of Government Studies found that 51.7% of its 4527 respondents say they considered moving out of state. Completes part A through C. Compute a 95% confidence interval for the portion of all Californians who considered moving out of state. So we are actually going to let our calculator do us absolutely everything here. Okay, so in order to make our calculator do what we needed to do, I need to have a value of n because I wasn't given that. So we're actually going to take 0.517 times 4527 so that I can figure out how many people said yes to this. Okay, so if I flip over my page and I look at that, that's going to be 2340.459, which I'm just going to take at 2340. So my proportion, when I get to my calculator, I am going to have 2,340 successes. Okay. That will actually be not my sample size. I'm using the wrong variable here. I got to correct myself. This is actually going to be x. Okay. Change that, and there we go. Okay. And then we'll have to interpret our confidence interval when we get back with this problem. So away we go. We're gonna kick out to our calculator here and see what we got going. So in my calculator, to get to that test, I wish I had an arrow here. Hopefully you can see me click. We're going to go to stat, and then we're going to right arrow, so we get over to test. We're going to arrow down until we get to a thing called a 1 prop z interval, because that's what we are creating. We're going to create a confidence interval based on one proportion, or a 1 prop z interval. So I'm going to hit enter on that. So this is where I need the number of successes. We decided from the other paper that we're going to have 2,340 successes is what we're going to have out of 4,527. Okay. The next is going to be how confident we want to be. And I actually forgot what confidence level it is. It looks like it's 90 if I can read that notes correctly. So there we've got 90%, and we're just going to go down to calculate, and it's going to give me everything that I need as far as there is my confidence interval. It is 505, so to 52.9. Okay, so when we do it in Excel, it's going to want you to round it. And in this case, it wanted you to round to the nearest tenth. So when we flip it over to the other side, or flip back to this, my confidence interval, and usually we write them like this, or if you're writing in class, this would be 505 to 0.529. However, in Math Excel, it converts everything to percents. So this is going to be 50.5% and a comma, and then it's going to be 52.9%. Okay, so this is what goes into MathXL. This is what it's going to want. All right. We are going to now interpret our interval in context. Okay, so this is where if we were in classes, or my kids hate it because they are writing tons of sentences. We are 95% confident. Actually, rephrase that. 95% confident. So I actually calculated the wrong one, didn't I? Okay. Well, we're going to scratch this out here. I'm going to undo this one. You guys are going to have a different problem anyway. So we'll scratch that out because I think we did 90% confidence, didn't we? Now I don't remember what we did. Stat, go to calculate, or go to test, excuse me. We're going to arrow down. And yes, we did 90% confidence. So that answer there is from 90% confidence. So we are 90% confident. The true proportion of Californians considering moving out So this is our ability to, again, figure out what is our population. It's the proportion of all Californians considering moving. Lies between 50.5% and 52.9%. Okay, we'll flip back and look at this calculator for a second. 2340, I had a population of 4527. Oopsies, why did I do that? And we'll calculate that. Nah, that came out right. Sorry, that seems weird. Anyway, there we go. And lastly then, on this problem, since the high cost of housing has often been cited as a reason why residents move out, suppose the state will consider investing in a new affordable housing if it can be reasonably sure that more than 50% of Californians would consider moving. What should the state conclude based upon our data? Okay, so what happens is we created an interval. That interval lie above 50%. So since the interval is above 50%, okay, that is going to give us evidence for government that government should consider housing alternative. Okay, I highlighted that because what happens here is when you go to do this in MathXL, it's going to have some fill in the blank stuff. So is greater than is going to be it's going to be is greater than or other reasoning rationale, and this is going to be should or should not, and then we'll go from there. Okay. I think I've hit my limit on the length of this video. Actually, we'll cut care of this page and then I'll stop and go to a different video. A student is considering publishing a new magazine aimed at directly at owners of Japanese automobiles. He wants to estimate the fraction of cars in the United States that are made in Japan. The computer output to the right summarizes the results of a random sample of 50 autos. Carefully explain what it tells us. Okay, so this seems very, I don't want to say very vaguish. But here's what we have. We have a z interval for a proportion. We made that with 95% confidence. And we have the interval that it said. So here's what it's telling us. Okay. we are 95% confident the true proportion of cars in the United States made in Japan lies between 33.9% and 49.3%. Okay, and there we go. The wording in Math Excel may end up being different. That's just the wording that I always use in class. And so again, like I said, Math Excel is like